Jimmy Carter, the U.S. president, who was himself a nuclear engineer, had served on a submarine as a Navy military officer. He proposed that we have a moratorium on all space activities in which there's nuclear power. His quote, which I think is appropriate to read, "If we cannot evolve those fail-safe methods," you can imagine what those might be, by the way, then I think there ought to be a total prohibition against nuclear-powered Earth-orbiting satellites. It raised the issue of the hazard in ways that we had not seen before. Follow that with the 3 Mile Island nuclear accident in the United States in March of 1979, and the public in the U.S. has much higher levels of interest in this subject than had ever been registered previously. And it changed the dynamic to the extent that in every single mission since that time, there has been some public response in opposition to it. 2 of those became quite significant. The Galileo mission to Jupiter that deployed from the Space Shuttle in 1989, and the Cassini launch in 1997, which was launched on a traditional Titan launcher. I'm only going to talk about Cassini at this point in time because of my time is fast approaching. Yeah, 5 minutes. So, mostly I'll just show you pictures, I suspect. So the public got excited about this. There was a Stop Cassini campaign. A small group of very ardent organizers proceeded to try to keep it from being launched. There was legal challenge. There was also direct confrontation. And you can see the protesters at Kennedy Space Center at the time of the launch in 1997. There had to be, as a result of this, increased attention to the processes that were put in place to maintain the safety of everyone. Public intellectuals got involved in this in ways that were interesting. Carl Sagan said, "Let me tell you, both sides have a point here, and people of goodwill on both ends can make the case that there is a risk, and it is real, and there's a reason, and it is real as well." But one of the things that got everybody the most excited was the fact that Cassini had a very strange mission trajectory. I've got to walk through this. So it is launched from Earth. It then continues inside to the inner solar system, has a flyby of Venus one time here, and that flyby of Venus gives it a gravity assist and speeds it up. Then it comes by Earth. This is where everybody gets excited. It's coming by Earth on another gravity assist trajectory, and what if it hits us instead of misses us by a very small amount of miles, and we get nuked in this process. So that was the major part of the concern. It was also one of the concerns associated with Galileo earlier, is that there's this Earth flyby that's a part of this thing. It's loose in the solar system and it's coming back. It would then go around, by the way, one more time, hit Venus, fly by Venus, and then on out to Saturn. Now the mission went successful. There's no doubt about that. It was actually a major success for NASA in terms of the scientific projects that resulted from that, and the European probe Huygens was also a part of that project, and it continues to be a major success right up to the present, really. Here's an example of some of the protest literature, and you can see that it's emphasizing the Earth flyby as one of the major problems associated with this. Now, just to bring this to a close, let me ask the fundamental question of any historical, actually anything. So what? Who cares? And this is at best a very preliminary discussion, but there's a whole variety of things I'd like to pursue down the road. There's a whole issue of technology development which we didn't spend a lot of time talking about today, or did I in this particular paper. That is the part that the engineers are most concerned about. I sat on a panel about 2 years ago for the American National Academy of Sciences that dealt with the issue of plutonium-238, the fuel of choice for these RTGs, and a restarting of the production line for it that had been out of business for a number of years. And we constantly debated the politics of how to start this thing, and I kept raising the public protest over this. And as the only social scientist in the room amidst a bunch of engineers and a couple of scientists, their response was, well, everybody knows it's a risk. We have to accept that risk. That's not what the public thinks. But I never was able to convince them otherwise of this. They're only interested in the technology and what it can do and the science that can result from that. But the interrelationships between federal agencies is a part of this. I mentioned this in the context of the AEC and Applied Physics Lab and NASA early on. The techno-scientific entrepreneurs, which we didn't talk very much about, but certainly Glenn Seaborg and a number of other people that are in the story are a part of that process. And their emphasis in this, regardless of any countervailing issues that might be present. I should also add to that group, by the way, the protest and the communities from which those protesters are drawn. And then this changing role of concern about safety for the public, which has evolved over time, and it's not a straight line. There have been numerous launches of spacecraft since Cassini that have also been protested, but not quite the same way, and certainly not with the virulence of the Cassini protest. And so morality, ethics, and choice are a part of the story as well. Anyway, with that, let me close, and I guess we'll move on to the next speaker, and then afterwards we can have a conversation. Thank you very much.